This video is going to continue looking at Chapter 8, looking at Section 8.2, writing and balancing chemical equations. So where we left off on last video, we were writing chemical equations going from words to symbols. Now we're going to make sure that we have the same number of each atom on both sides. So let's take a look at this one. We're going to go from mercury 2 oxide to mercury plus oxygen. And so we know that mercury, since the Roman numeral is there, it's going to act as positive 2. So when we write mercury oxide HgO, yields mercury plus O2. And as you can see here, we have one mercury on the left, one oxygen on the left, and on the right we have one mercury and two oxygens. And so how you need to get practice with these is just keeping track. So as we have 1 and 1, we have 1 and 2. So remember, subscripts are going to become increasingly important during this process. So we're going to need to change how many oxygen atoms we have on our reactant side. So we can go ahead and put our coefficient in front. So we're going to have a 2 mercury oxides yields mercury plus oxygen. Now we have 2 and 2, 1 and 2. So what's our problem now? We're going to need to balance our mercury. So all we need to do here is to add a 2 on both sides, add a final check. We have 2 mercuries on our left, 2 oxygen atoms on our left. Now we have 2 on our right, 2 oxygen atoms on our right. So don't get confused about changing subscripts and coefficients. You can never change a subscript in a reaction. You can only add coefficients. We also need to note that our coefficients need to be our smallest whole numbers. So in this case, if you wanted to write coefficients of 4, 4, and 2, that would be balanced, but it's in our correct form as we need to have our smallest whole numbers across the entire chemical equation. More practice. So here we're going from magnesium metal undergoes combustion to produce magnesium oxide. So it's going to be the same reaction, only in reverse from the last one. So we'll have Mg plus, again, oxygen being one of our diatomic elements, yielding magnesium oxide. Again, you can see we have our same problem. We're going to have 2 oxygen atoms on our left and 1 oxygen atom on our right. So here we can actually balance our oxygen first. So we're going to add our 2 to our products. Again, often best to balance our metals first. So we're going to see that we have 2 magnesiums and 2 oxygens. And now we'll just need to make sure we have magnesium balanced on our reactant side. We add a 2 as a coefficient. We now have 2 of each on both sides. Here's a checkpoint that I want you to work through. Given these words, I have the reaction in chemical formulas as your options, but pause the video now to work through balancing them properly. Okay, so how do we start? We have our reaction skeleton, our unbalanced, so we know that it's going to be butane C4H10 plus oxygen because there's combustion, yields carbon dioxide plus water. So we're going to write our unbalanced skeleton equation. First thing we're going to do is add our balanced amount. So we can see here we have 4 carbon atoms, 10 hydrogen atoms, and we added 6.5 to give us 13. We now have 4 carbon atoms, 10 hydrogen atoms, and 13 oxygens. Our problem here is that we have a half number as a coefficient, so these cannot be our final balanced equation. We need to multiply everything by 2 to give us whole numbers, and you can go ahead and check this. All of our atoms are going to be individually balanced, and that's the end of video 2.